Hello and thank you everyone for attending today's webinar, Linear Guides 101, the Basics of Linear Guide Technology, brought to you by Design World Magazine and Bishop-Wisecarver. We would like to thank our presenter, Brian Burke, for being here today, and Mike Santora, Associate Editor for Design World Magazine, and I'll be your moderator. Just a couple of housekeeping details before we get started. You will see several boxes on your desktop, all of which can be moved around to suit your preferences. Initially, the Q&A box is on the left-hand side of your screen, and this is where you will enter your questions for the Q&A session. Another box to note is the additional resources, initially in the lower left-hand corner of your desktop. These resources are for your information needs. There is also a taskbar at the bottom of your screen to help you navigate the webinar. Brian Burke, Senior Product Manager at Bishop-Wisecarver Group, has more than 14 years of experience in the automation industry. He has extensive experience on the manufacturing production floor, including CNC machining, lean manufacturing, new equipment acquisition and implementation, and process optimization. With an educational background in manufacturing technology and computer-aided drafting and design, he is passionate about product development and the process of bringing new ideas into reality. He is a Six Sigma Black Belt and a Certified Product Marketing Manager. And so, without further ado, here's Brian Burke.
Thank you, Mike, for the great introduction and for being our host today for this webinar. And a special thank you to Design World Magazine for promoting this webinar and placing it also on their platform online. And today we're going to talk about Linear Guides 101 as a basic introduction to linear guide technology. But before we get into that, we're going to take a brief look at who Bishop-Wisecarver is, the products that we manufacture, and the markets that we typically serve. This is intended to give you an idea of what our core business is. Then we'll get into the main webinar topic here about linear guide technology. There are many common types of linear guides available on the market today, and so we're going to take a look at what those are, as well as some of the terminology and jargon associated with them. We're going to look at the key benefits of V-groove linear guide technology and also explain the various types of bearing protection. Later on, it gets a little bit more advanced. We'll look at how the life estimates are done, and then we'll look at maintenance tips for maximizing the usable life of linear guides. We'll follow that up at the end with questions and some additional support information. As Mike mentioned, if you have any questions, please enter those into the webinar software. And if we don't get to your question at the end, we'll be sure to reach out to you to answer any of those questions later. Bishop-Wisecarver is actually Bishop-Wisecarver Group, and it's made up of 3 subdivisions. BWC is our linear and rotary motion system business, where we are the original equipment manufacturer of these automation products. With Black Diamond Manufacturing, or BDM, is our specialty contract manufacturing branch. This is a one-stop shop for custom complex assemblies, machining services, and other manufacturing turnkey solutions. WRW is our electrical and software engineering branch, which is known mostly for control systems and design expertise. Bishop-Wisecarver has a strategic partnership with a company called Hepco Motion. They're located in Europe, in England. They sell and distribute our products throughout Europe, and we sell and distribute their products throughout North America. Bishop-Wisecarver is the exclusive North American distributor of Hepco Motion products since 1982. We have many different product lines, and I like to explain our wide range using this image. It's contained within what we call our evolution brochure. On the left-hand side, you can see the individual pieces and parts. So these are our components. The core of our business is based around these guide wheel products in the Dual V product line. These parts can be selected and integrated into equipment or directly onto machine bases or frames. Moving to the middle, we have subassemblies where the components are pre-installed and adjusted to linear elements, such as is the case in our Utilitrack and Low-Pro product lines. These function as heavy-duty linear guides. Moving over to the right-hand side, we have our complete actuators that can be combined into gantries or multi-axis motion systems. We have many accessories such as drive motors, motor mounts, travel sensors, and a wide assortment of additional items. There are also many products available from HEPCO Motion, and these products are quite unique. HEPCO makes rings and curved sections that can be joined together with straight tracks to make up curvilinear motion systems. On the right-hand side, we have our components, such as the guide wheels and rings, or ring segments. Sub-assemblies in the middle are also available in standard guide wheel-based carriages and standard ring diameters. The rings can be driven with pinions and feature optional gear teeth that can be added to the internal or external surface of the rings. There are many different standard ring cross-sections and diameters, and for many of the sizes, there are matching straight rails. These parts can be combined into interesting shapes, such as oval systems. Looking towards the right-hand side, you can see that these can be driven motion systems. These complete solutions are used for high-frequency assembly and packaging applications in factory automation and equipment environments. Bishop-Wisecarver has been providing linear and rotary motion solutions to a wide spectrum of industries for over 65 years now. You can see here a couple of our primary industries that we service. Applications in food processing, such as in packaging machines and food handling and case packing and case erecting. We're also used in medical and pharmaceutical production, perhaps in tabletop analyzers or laboratory inspection machines. Our products can be used in transportation, such as on train doors or passenger platforms, or even luggage or baggage handling equipment. We're used in aerospace and defense on machinery such as welding positioners, and also on some production floor fixtures like lean workstations or material holding applications. But in general, our primary use is in industrial machinery and automation. This is a very large bucket, and it's in fact growing in the recent years and more focus on American manufacturing. But industrial machinery includes many different types of machines, from basic material handling to specific dedicated machines that do very specific tasks. So you can see here quite a wide range of uses of these products. Okay, and back to the agenda slide. We've now completed the overview of the markets and the products that Bishop-Wisecarver manufactures and supports in industry. Now it's time to start into the core topic here, the basics of linear guide technology. So let's have a look. Okay, so let's say I'm lazy, like really, really lazy, and I don't want to do a whole lot of work. I'd rather build a machine to do that work for me. Whenever you walk through a jumbo store and you see pallets of products sitting there waiting to be purchased, those were not put there by people. People didn't put those products into those bundles. Machines were used to do that. You can see here some examples where bundles of 6 or bundles of 12 products are placed on a cardboard flat and then shrink wrapped. That type of work is done at the end of a production line using a packaging machine. So in this case, we're going to use this example of this packaging machine. It does bundling and shrink wrapping. And you can see how big it is. I mean, it's a fairly large machine, but it has a lot of linear guides, small motions inside that machine that need to be guided so that when product goes in one side, it comes out all complete and done on the other side with no real human interaction. You can see here just one person monitoring that screen or overseeing that everything is running perfect in there. And so this is a typical application where linear guides might be used. Okay, so what is a linear guide? You might have seen some. There's a lot of common types. Here's some of the terminology and jargon associated with that. A linear guide is essentially a bearing that provides free motion in one direction. They have a lot of other names that people might call them. They might be called a rail, a track, a profile. Some people call them a slide, maybe a guideway, or a linear bearing. You can see here different types. Most of them are ball bearing based, but there's also sliding element based. We're going to look at guide wheels in depth today, but there's also square rail, round rail, and also these sliding elements that can be on round rail or round shafting. That packaging machine that's going to allow me to be lazy doesn't just package products with linear guides alone. It's going to need motors to give power to different drive mechanisms that are going to make those different elements move in an automated fashion. And so here's the different types of drive mechanisms. These are mechanical parts that convert power into motion. You can see here belts, chains, ball screws, lead screws, and rack and pinions. There's probably several other types of drive mechanisms, but from my perspective, these are the most common. So when you combine these two things, you get what we call an actuator. It's essentially a linear guide plus a drive mechanism plus any accessories needed to make it a total solution. And of course, there's some terminology and jargon associated with those. An actuator, the definition there, is a mechanical device for moving or controlling motion. Some other companies might call that a stage, a thruster, or a positioner. There's two different types as well. They're not always in a linear. They can also be rotary. So a linear actuator is a device that creates motion along one axis or along a straight line. A rotary actuator is a device that can create motion around a circular axis. So if we go back into my packaging machine and take a closer look at how these elements are constructed, you can see that there are many different linear guides and motors and drive belts, pneumatic cylinders. There's all different kinds of products necessary to make this machine do all of that type of work. But in general, linear guides are needed to control the axes of motion to ensure that it's repeatable and the products come out the end without damage and properly packaged the way they need to be. So many of the axes of motion on this packaging machine are using the guide wheel technology for the linear bearings. So you can see here a close-up shot of two of those linear bearings and a close-up view illustration of how those are made up. In the case of the V guide wheel bearings, the bearings themselves, the dual V wheel is mounted on a bushing and bolted down to a carriage plate or a mounting surface. They're done on mating 90-degree V tracks. And so by attaching these to the machine frame, these linear bearings or guide wheels can provide smooth guided motion along a straight axis. And because they're component-based, like an individual component kit, they can be attached or mounted where needed, and then it's very flexible for how they can be used. In the case of this packaging machine builder, they like the idea and the concept, and they've applied it to many different axes of motion within that same machine frame. So let's take another look at these linear guide components. The guide wheels themselves have internal ball bearings. They're essentially a 90-degree double row angular contact ball bearing. That means that the balls are mounted in a double row and they contact the outer race at an angle. This angle allows it to accommodate loads in multiple directions, which is a great feature. These bearings typically have a hole through the middle, and so you'll need a way to mount them. There's a couple different ways. There's bushings or journals. In the picture down below, you can see the bushings. There's two different types of bushings, a concentric or eccentric. The concentric has a round base and is not adjustable. It's for putting a guide wheel in a fixed location. The eccentric has a hex with an offset hole. you can mount those and adjust the offset with the hex using a wrench. This allows you to do fit up to a track, which is a nice feature as well. The linear guide track has a 90-degree running surface that matches the 90-degree surface on the guide wheel. These linear guide tracks can be very long, and they're available in different sizes, as you can see from the image. And so with these component parts, you can select and pick and choose the right pieces and parts to build up your linear guide. V-Groove linear guide wheel technology has several benefits and advantages. Primarily, these provide very smooth, quiet operation with high load carrying capacity. They're made from high-quality bearing-grade steel in carbon steel and stainless steel, which is hardened for durability. They also have precision ground running surfaces that help it be accurate and quiet. They feature very low stiction or coefficient of friction. This is because the wheel has a fairly large diameter and it doesn't take much effort to get it rolling. Another advantage of this is that it can traverse small gaps in the track. Because the wheel is fairly large, it can easily roll over a small gap. These provide industrial-grade performance, suitable for continuous use operation in production facilities such as my packaging machine. The most significant key benefit to using guide wheel technology is the associated wiping action that's generated during use. The V feature on the wheel matches the V feature on the track. And if you take a close look at the running surfaces of the V wheel, the area near the V intersection is a smaller diameter than the area near the outer diameter. Therefore, when the wheel rolls on the track, there's a difference in peripheral speed. With each revolution, the inner V area travels a shorter distance than the outer V area. This difference in peripheral speed can be called a velocity gradient. As the wheel rolls, it's constantly wiping from the peak of the V to the outside. Naturally, this works well in a clean environment, but the design is also an ideal solution for use in dirty environments where the self-cleaning wiping action is of the most benefit. Another key benefit to guide wheel technology is the fact that the critical components, the ball bearings, are located internally inside the guide wheel. They're protected by seals or shields, which help to keep the debris out and the grease in. These wheel bearings are lubricated for life and do not require maintenance, although it is recommended to provide a light oil lubrication on the wheel-to-track interface to lower the friction. Let's compare this to recirculating ball linear guide technology, where the ball bearings roll directly on the exposed linear rail. Any debris must be removed by the wiper seals, and dirt ingress will lead to very rapid failure. There is no wiping action on a profile rail, and the seals must push the debris ahead of the balls. All right, so let's look at the different types of bearing protection and where they're most suited so that you might be able to select the right type for your application. You might have heard one of the most common is a seal. A seal is actually made out of a rubber compound, in this case NBR rubber or nitrile butadiene rubber. It's mounted into a groove on the outer race of the bearing, and it actually goes and lightly touches the inner race. This is great to keep small particles and fines outside of the wheel, and it helps to keep the grease inside the wheel. One of the disadvantages is that light contact adds a little bit more friction, so it has a little bit more rolling resistance. This is also the lowest cost solution for bearing protection. It works very well, it's low cost, and so it's adopted on many bearings. Another type of bearing protection is called a shield. It's made out of steel or stainless steel. It's also attached to the bearing in the same manner, where it's installed into a groove on the outer race. Because it's metal and we don't want metal-to-metal contact, it stops just short of the inner race so that there is no metal-to-metal contact. This little gap, though, allows small particles to get in there. So these are better suited for large particles like large chips, like wood chips or big metal chips, things like that. These are also better for high temperature applications where a rubber might melt, but this metal shield here is going to withstand a higher temperature. That would be good for hot sparks like in welding applications. And it can also take somewhat of an impact. If something were to hit it, it won't deflect. It provides a bit more protection. In general, it costs a little bit more money, but it's also very common and commonly available. BWC has some unique bearing protection in the seal shield combination, and it's essentially a hybrid of both technologies. It has a stainless steel shield on the outside and an NBR seal on the inside. You have to look closely at the image to see the little black line where the rubber is, because it's mostly covered by this stainless steel shield. This provides the best of both worlds. It can take hot sparks, large particles, impacts, and also reasonable temperature ranges, while the rubber seal on the inside can accommodate for small particles. And so this has advantages for basically overlapping both of those technologies into a single package. The last type of bearing protection we're going to look at today involves the washdown wheel. This is patented technology by Bishop-Wisecarver, so it's only available by BWC. This is a double seal technology. It's intended for high-pressure washdown applications where caustic washing and frequent cleaning is required. So you can see here it has a double seal. The inner seal is fairly traditional. It's mounted to the outer race and it slightly rubs on the inner race. The outer seal also mounts to the outer race but stops just short of the inner race. This one is fairly special because it's flexible. It will deflect under high pressure water, and that water will then be blocked from entering inside the bearing. When the high pressure is removed, it will relax and expand and allow for drainage of any fluids that were trapped. This is great for cleaning and keeping the grease inside the bearing. So if you're considering using V-groove guide wheels for a linear guide application, you might want to be concerned with the load and the life considerations. The load is how much weight can this bearing handle, and the life is how long is this going to last. And so the number one important thing that you need to worry about is lubrication. We always recommend lubrication. You can run a bearing on a linear rail without lubrication, but it results in approximately 90% reduction in service life. So it's critically important to lubricate that product. You also might be concerned about the types of contaminants and amount of it. Light sawdusts are very soft and can be pushed out of the way easily, and so those aren't much of a concern. But you might have maybe ceramic tile dust, which is very hard, and it might be in a slurry, and so that could be very abrasive. You might have to worry about that a little bit more. Vibrations and impacts are also not a good situation for guide wheels. You can make small dents which do not spring back, and so any dents or deformation of the steel could lead to a longer-term problem. Of course, you might want to look at operating temperatures. What's the range that this product will need to operate in? If it's extremely elevated, it could melt or wear out sooner. And if it's very cold, it can also cause problems with the grease. The duty cycle is how frequently it's to be used. If it's used day and night very frequently in high-speed applications, the life will be consumed very fast, how long it will last. The wheel spacing is important because a wider wheel spacing will allow you to carry a load further away from the rail. That's really just dynamics there. Also, the orientation is one of the considerations. Because the internal balls are mounted at angular contact, They do different amounts of load capacity in the radial direction or the axial direction. You might want to look at the loads that you're going to apply, maybe even the velocity at which the wheel is going to move, and also the accelerations, how quickly you want it to get up to those velocities. So you need to kind of balance all of these considerations and really think about your application when you're considering using guide wheels. But remember, if you know your loads, it's easy to then select the right wheel bearing and then calculate its estimated life. And if you don't like that calculation, if you're not happy with the life that it tells you, you can go back in and adjust it with a bigger bearing and get longer life. So we'll take a look at some of that. So engineers can calculate the expected life estimate, but I think it's fairly simple to use the equations, and I think just about anyone can do these calculations. It's a simple three-step process. Step one would be to calculate the loads on each bearing in a motion system. Step two is to calculate the load factor for the most heavily loaded bearing. And then step three will be to calculate the life estimate by using the load factor in the load life equation. One of the other pieces of information you'll need is the life constant. This is the distance of travel that each bearing can travel with full load. So that is the standard calculated life of the bearing. So we're not going to go any deeper into the load life calculations, but it's very simple and the equations are available in the catalog. If assistance is needed, application engineers at BWC are available to help calculate and make recommendations. So let's get on to maintenance to maximize the service life to ensure that your motion system can reach the stated or calculated life estimate. So one of the most important accessories you could include is the lubricator assemblies. These help to wipe debris from the guide track away from the wheel to track interface. The oil-saturated felt continuously dispenses lubricant. This lubricant helps to reduce the friction, reduce the wear, and reduce the corrosion. So you can see here these are just a few simple mechanical parts that you can use to really help maximize the life of a guide wheel motion system. There's another type of lubricator that we call a wheel cover assembly. These also wipe debris from the track, but they mount around the guide wheel. They actually have two oil-saturated wiping felts. So these are great because they can push debris in both directions away from a guide wheel. So they also continuously dispense lubricant to reduce that friction, wear, and corrosion. The added benefit of these two, though, is that with a wheel cover, it reduces any pinch points on the wheel to track, and it puts the wheel to track interface, which is good. And so with these lubricators and wheel covers, it's important to always periodically re-lubricate the felts with oil. You want to make sure that there's a light film there so that it can be of the most benefit. So here we have a pro tip. You can actually apply lubricant directly to the linear track surfaces using a hand towel. You can take that oil lubricant, apply it to a little towel or rag, and wipe it directly onto the rail. You don't actually have to completely disassemble this wheel cover by removing the screws, removing the felts, re-oiling them, and then reinstalling it. You can simply periodically just apply it with a rag. Saves you some time. Okay, so those were some of the basics of the guide wheel technology. So if you have an application in mind, you might be wondering, where do I start to figure this out? What you want to do is you want to think about your application in pretty great detail. You want to think about the forces that might be involved, static and dynamic. A static force is not moving when it's at rest, and a dynamic force is the forces when it's moving. So if you have a heavy mass moving at high speeds that you want to slow down, like when you slam on the brakes in your car and your head goes forward, your neck has to resist that. So there can be high dynamic forces in a system. What speeds do you want this to travel at? What accelerations, how fast do you want it to get to that speed? Of course, the duty cycle, how many times you want that to do that motion in a day. The different environments that it might be in. Is it dirty? Is it clean? Does it have hot sparks, fine powders, big metal chips? What is that environment? Of course, you might want to think about how long you expect this motion system to last. You don't want it to wear out in the first day, but you also might not need it to last 10 years. So think about your needs there. Also, what types of lead times you're considering, and also the cost. If you size a larger bearing system to get longer life, it will cost more. So you can get a less expensive system that won't last as long. So there's always some trade-offs there. You can see here some graphics that I have when you think about the different forces and the directions. There's actually 6 different directions of force that we use to calculate bearings. And I like the space shuttle analogy. We have the pitch, the roll, and the yaw. So pitch is bringing the nose up and down of the space shuttle. The roll would be tilting the wings, and the yaw would be like adjusting the rudder, so pointing the nose. By applying forces in these directions, it creates essentially a torque on the carriage. If you know those, it's easy to calculate and size a system. So one of the best ways to outline your thoughts on your application is to use our application data sheet. And sometimes the questions on the sheet will prompt someone into thinking a little bit more critically about their application, like, oh, I didn't think about that. I have missing information. So some of them is there, like what we've been talking about, the duty cycle and things like that. So someone can fill this form out and submit it to Bishop-Wisecarver for recommendations. So we're actually here to help you in that process. The next thing you might want to do is research the available options that are out there for you. There are many different products designed for specific environments, and there's a chance that there's an existing product that's meant for the application that you're thinking about doing. So there are products designed specifically for high temperature applications, maybe in industrial baking or welding or other areas like that. Also, there's low temperature specific products, maybe in flash freezing or frozen food handling, something like that. Of course, corrosion resistance is usually important, so there's many products in that. But there's a new product out there which is a food grade product, which has food grade grease, which is available for food packaging. Of course, today we talked about the washdown with the double seal technology. So if you have a food production application, there's washdown. And the last one on here is vacuum. There are some products specially designed for vacuum environments. Those can be used in testing chambers or other science R&D applications. So just think about the specific environments and what your requirements would be for the materials and your possible solution. Okay, so this brings us through to the summary slide. Today we looked at the basics of linear guide technology. I provided you a basic overview of how Bishop-Wisecarver and HEPCO Motion make automation products for many different industries. We had my analogy of a packaging machine where I'm very lazy and I don't like to do work, so I need linear guides to do that motion. We talked about different terminology and jargon with the different types of linear guides. Guide wheels, square rails, round rails, sliding element bearings. We talked about a couple different drive mechanisms, belts, chains, ball screws, lead screws, and rack and pinions. We briefly touched on actuators, linear actuators, rotary actuators, and what those mean for a motion system. We took an in-depth look at guide wheel technology. We looked at the wheels, the bushings, how they mount, and the tracks that they roll on. We talked about many of the different benefits to using guide wheels, how they can provide smooth and quiet operation, even in heavily dirty environments. We looked at all the different bearing technology protections that there are, seals, shields, seal shield, and the double seal washdown version. Then we talked a lot about the concerns that you might have for use in your application, how to calculate the life estimate. We looked at maintenance, how to keep it running a long period. You know, we're mostly concerned about lubrication. We looked at lubrication kits like the lubricator and the wheel cover. So we went through quite a bit of information today. There is more information behind it. So if you have any questions or where we can guide you, please submit a question or look online on the website, bwc.com. With that, we're going to pass it on to the questions and answers section. If we don't have time to make it to your question, please note that we'll follow up later. So again, thank you very much for attending the webinar. Okay, so I see some of the questions here that were submitted during the webinar. Let's take a look at some of these. First question I see here is, what are the temperature ranges that guide wheels can use or work in? Yeah, that's a very good question, and there's a chart in the main product catalog. The cold bearing, or the low temperature bearing, can go down to negative 34 degrees Fahrenheit, and the high temperature bearing can go up to 500 degrees Fahrenheit. So you can see that there's a very wide range of temperatures that are possible. Okay, another question is about what are the materials of these linear guides? That's a good question, and we didn't talk about that at all during the webinar. So the typical product is made out of carbon steel, and it's actually 50-100 bearing grade carbon steel that's heat treated and hardened. The stainless steel or corrosion resistant version is made out of 420 stainless steel, and this is 400 series stainless steel. We use 400 series because it's able to be hardened through a heat treating process. So it's not quite as corrosion resistant as a 300 series, but it can be hardened and is much more durable for a linear motion application. There's a question here that says, what's the longest linear guide you can manufacture? That's a good question. I touched on it briefly that the linear guide tracks can be mounted end to end and with a little joint, and the wheel can roll over it. The individual tracks themselves are manufactured in lengths up to 20 feet long, and they can be joined end to end. We've completed motion systems that are 80 feet in length, and they can be made longer. And so a motion system like that would have, 4 20-foot sections mounted to a base. Okay, the last question that we have time to look at today is about, it says here, how do I mount a linear track? That's a good question. Typically, the linear tracks have standard hole patterns that are through holes down the length in the long section of it, which we call the heel. Those through holes are meant to install into a threaded hole with a bolt. So you would just align the track to the surface and then screw it into a threaded hole. They're also available with threaded holes on the tracks, so they can be mounted with a screw from underneath and tightened down. That's a good solution because there's not a head of a bolt sticking above the rail or above the track. Okay, so that brings us to the end of these questions and answers. I encourage you, if you do have any additional questions that we didn't get to today, to please submit them on the webinar or go ahead and contact us directly. So again, thank you very much for attending this webinar, and thank you to Mike Santora and the Design World team for promoting and hosting this webinar today. Thank you very much, and happy designing.
If you have any additional questions, you can refer to the speaker bio box containing contact information for Brian or myself. And lastly, of course, thank you everyone for attending this webinar from Design World. This presentation will be emailed to everyone later today and will also be available at www.designworldonline.com.